Good morning, good afternoon, good evening. My name is Alex Volkov. I'm a solutions architect for NVIDIA, and I will be presenting regarding how to share a DGX system. So this is a common use case that we encounter when you have a team of data scientists and they're sharing a DGX or a GPU server, and they want to coordinate. They have multiple people using it. So this is what we will cover. Let's begin. So our agenda for this presentation for today is to go over basically what a DGX is, how you might use it, what it's for. And then we'll talk about DPops, which is it's a set of scripts and utilities that will help you deploy various services on the DGX. And after that, we'll cover about how you monitor and manage the GPUs on the system in the shared environment, as well as logging, user logs, and running jobs, and as well as how you handle workloads, which is running containers and such. Okay, so what is a DGX? So DGX is our NVIDIA solution. It's a universal system that we use for AI, data science. You can incorporate it in your infrastructure, and so many organizations have incorporated DGX into their data centers, again, from analytics to training, inference services. And the challenge, again, or what you might have, is you might have several of these systems in a cluster, or you just might have one system. So in the use case of one system, this is what we're going to focus on. So let's say you currently have a one DGX system, and you have multiple users on it. How do they organize? How do they use the resources on it without stepping on each other's toes? So if you have a cluster type of API, then you can use that, and that will coordinate your reservation of the resources in the system. On the other hand, if you don't have that, you might resort to sort of these crude reservation approaches. It could be just a first come, first served. You could have a sign-up sheet. You might try to use some isolation mechanisms with, there's a few knobs to do that with CUDA visible devices and such. So the problem with those approaches is they're not enforceable. They could be inconvenient because you have to have coordination between users that's not automated. So what we suggest is you can adopt a cluster type of API, which doesn't require these types of manual coordinating between users, and you can just resort or rely on the cluster API. So let's just go over briefly what a cluster API is. So cluster API has many benefits. You can automate and enforce resource reservations and scheduling. Users are prevented from direct access to the hardware without first reserving it through the API. And so some of the resources that typically cluster API will manage for you is, again, GPUs, CPUs, memory. And that way you can, admins also have control over policies, and they might incorporate priorities, saying some particular project or maybe users need to have priority on a given day for the resources. But when it's not used, you can let others use it. So you have advanced scheduling and all sorts of approaches to manage your resources. In this case, what I'm showing here is a Slurm example, which is what we will be using with DeepOps as I go through this presentation. So briefly going over some of these Slurm commands, let's say scontrol and saccount. These commands, or I like to think of them as APIs, these let admins control the policies, user accounts, limits for jobs, job time duration, for example, limits on hardware. Maybe you're not allowed to use up more than 2 GPUs at a time, or have more than 2 or 3 jobs at a time. So sinfo, sq, these are APIs to do query of your resources and to see who's running what, perhaps to log things. And then you have the actual launch commands, which are srun, sbatch, salloc. For example, there's also scancel command. So these actually let you start jobs and stop jobs. All right. So in the single node case, you have to set up, in the cluster API slightly specialized way, because cluster means you have to have multiple nodes. But we want to be able to run this in a single node. So we can do this with a few caveats. So the DGX is modified in a way that you might initially, when you bring the system up, you will see all these GPUs. You might have 8, or if you have a DGX-2, you might even have 16 GPUs. So you want to prevent users having access to these GPUs. So we modify, we tweak some settings to hide the GPUs through regular SSH sessions, and instead the users are forced to use Slurm. And Slurm is tweaked in such a way that the login and compute services that Slurm runs on the node, they don't conflict with each other. So how do we do this? We do this using DeepOps. So this is what I'm going to discuss. DeepOps. So DeepOps is, it might be kind of difficult to explain this whole scope of DeepOps, but DeepOps is our project to encapsulate best practices in deployment of GPU servers and clusters, and sharing as a single node as well. So DeepOps is very modular, and you match to your site-specific needs. So let's go into detail a bit about what DeepOps has. So DeepOps is basically a collection of automation tools and scripts, and it lets you set up login nodes, management, monitoring. The full scope of DeepOps also covers Kubernetes setup, Slurm setup, and storage provisioning. So, but the typical full scope, where if you're gonna deploy Kubernetes and additional specialized nodes for storage, and same, and other specialized maybe management or provisioning nodes, that would typically require multi-server setup. So for the specialized use case here, what we are discussing is DeepOps in a single node setup. So in this case, the DeepOps will limits what it is it's going to deploy. So because what you're trying to do is set up a compute functionality, but also have it manage login sessions. So again, this login, what you would typically have is login sessions are meant for regular SSH sessions, or however the users log on to the machine. And the GPU devices, resources are limited in this case in your regular login session. But from here, you need to start a job, say a Slurm job. And when when you need to run something in a GPU, you start a Slurm job, and then you are granted the GPU resources that you ask for. All right. So the setup is relatively straightforward. It's kind of broken down here into 5 steps. So you clone the repo, you run a few scripts. The particular one thing here, additional optional here step, is installing rootless Docker, which we will talk about. So the rootless Docker has several benefits in this unprivileged Slurm environment that we want to set up, because we don't want users to bypass or have privilege escalation. And in this, and also rootless Docker plays well with Slurm in that it doesn't bypass the resources in any way. There will be a demo section later on where we will demonstrate this and go over this in some more detail. So monitoring GPUs. DeepOps, as part of the installation, it will deploy several monitoring services for you, particularly Prometheus. You might be familiar with that. And Prometheus, under the hood there, it collects many metrics that you can feed to its database. You can also set up alerts. So if you want to watch that maybe something is wrong with the system, you get an alert, or perhaps you have some kind of policy and some policy violation, you can set up alerts on that. By default, DeepOps installs the Prometheus service and lets you write additional alerts or dashboards that you would like to do. But by default, only a single Grafana dashboard is provided that gives you Slurm monitoring and as well as GPU resource monitoring. So additional alerts and metrics can easily be added. So, okay, let's go over the use case. So you have multiple users now that DeepOps is deployed. You have Slurm set up. In practical sense, how do multiple users run and what kind of jobs can they run? So initially, users, again, SSH onto the box, and you can't use the GPUs yet. After that, you can, again, maybe log in again, so you have multiple login sessions, because those could be useful. One could be for launching jobs, one could be for running jobs, etc. So once you're logged onto the box, you have to request a GPU. So for that, DeepOps deploys the Slurm cluster management software on it. And so the job allocations will specify the options for how many GPUs you might desire, how many tasks, etc. And you could have maybe a user running Jupyter Notebook, another user running some kind of machine learning workflow, a deep learning workflow, whatever it might be. Let's go. Now we're getting closer to the practical application. We'll jump into a demo soon. So how do you run workloads on the DGX? The DGX is meant to be an appliance. So ideally, you can containerize your workloads and run containers. The containers that we provide are available on NGC, which is NVIDIA GPU and Cloud Container Registry. I might demo that in a bit. So you should ideally use the containers available there, or you can build on your own. And so the ones on NGC have been tested and optimized, particularly for DGX as well. And the container runtimes, we actually provide several runtimes. The containers themselves are maintained in Docker format. But when you're on the box and you want to run them in an unprivileged manner, again, you have three options. A rootless Docker, which gives you the same API, but it's unprivileged. There are a few limitations to it, but for the most part, you can do all that common Docker workflows that you might be familiar with. Additionally, we set up Singularity on that. So Singularity is similar to rootless Docker, but it's, again, some privileged. There might be benefits in the future, and anything I say with Singularity also applies to Enroot and Pixis. And when you run multi-node jobs, if you ever expand to cluster multiple DGXs. The APIs for Enroot and Singularity are very similar to Docker. Again, you have push, pull type of commands. Run, import type of commands that you can run your containers. So one additional benefit with Enroot is it has a plugin called Pixis. It's a plugin for Slurm, and Pixis simplifies launching jobs on Slurm quite a bit, which we will demonstrate in a bit. So rootless Docker. Conceptually, how does this work? A user starts a Slurm job. Then they would have to start the rootless Docker daemon because it's not a constantly running service. The rootless Docker, each time a user starts a job, they have to start up this rootless Docker daemon because it only applies to them. And then after that, they just run regular Docker commands. They might be used to Docker pull, run, you could even do push, etc. So I'm going to jump to a terminal now and demonstrate how a user using, let's say, this rootless Docker approach might start a Jupyter Notebook session. So switch over. All right. So you currently should be seeing a terminal. So the first thing I'm going to do is I need to get on the machine. So I'm going to pretend to be 3 users. So I'll start out as being user 1. Right now, this machine is remote, so I have to SSH to a remote location to get to it. All right. All right, so I'm going to kill this for a second. Because I was already running a job as this user, but I want to start from the beginning to demonstrate how this might work. All right. So currently I'm on this DGX machine, and you only see a single DGX node available here. If I want to start a job on it, I can't just run a container or anything right now because I don't have access to a GPU. So if I run NVIDIA SMI, I will be told no devices were found. So first you have to start a job. So in Slurm, this is done typically. There's a few commands to do this, but srun is for interactive jobs. So I will start srun. If there's available resources, it's interactive, should drop you into a compute session. In here now, I have access to a GPU. You can see I have a D100, which is a 16 gigabyte version here on this DGX, but I only have access to one because here I specify that I only want one GPU I said GPUs per task is 1, and I only ask for 1 task. At this point, if I want to run Docker, let's say Docker images, I will be told you don't have permission to run Docker. What you have to do is you have to start rootless Docker. So DevOps deploys something called modules to handle some of the software on the machines, such as we have an HPC SDK. This might be useful if you don't want to run containers and want to run some kind of low-level CUDA work. You can do that with this HPC SDK. But another thing you might notice is this rootless Docker is one of the modules. So what you want to do is you want to load it. Once it's loaded, you will see it's available, and there's a few scripts that are added to your path. So one of these scripts is called start rootless Docker, and I will give it an option quiet. So quiet is, if I didn't do it with quiet, it would print out a lot of verbose messages about how it starts up. At this point, if I run Docker images, you will see the images. So these have already been pulled ahead of time. But let's just quickly demonstrate that. Here I have some work that I might be working on with currently, and I want to, again, what are we trying to do? We're trying to start a rootless Docker container, a Jupyter Notebook session. So I already built this container, but if I wanted to, build it again, just to demonstrate that the API for building works, I could do Docker build, and it will build the container for me. All right, the container has been built successfully, and I could push it to save it for future for in a private registry, such as you should typically have a NGC private registry access with your DGX. And now I'm going to start the container. So I'm within the container right now. I specified that I want to run this Rapids PyTorch container where I combine Rapids and PyTorch. And after this, I'm going to start a Jupyter Labs session here. So these are commands. I could write this in a script and just automate this. But for now, I'm manually starting up my container, etc. So let me copy this. And I would go to the IP address of the node. And I already had this before, but I might need this login token. And hopefully it will start up. Okay. So now I'm in running the container, and hopefully I'll be able to run this notebook. So what I like to do is there's a few convenient dashboards that Rapids provides that will let you monitor your GPU resources. So let's put these to the side. So as we're working, we will see things start up. So while this is still starting up here, let's just take a look at the same time at the dashboard. So these are the monitoring capabilities I was talking about earlier. In here, this particular dashboard it lets you monitor the Slurm, your Slurm cluster, and say how many Slurm jobs are running. You can see what's completed. So currently I can see, it might be small on the screen, but you can see running jobs is 3. If there's issues with any particular node, let's say there was a node that was down at some point, you can see when. And you could add additional metrics and alerts. So say when a node is down, you could set up an alert and give your query the reason for it. The GPU monitoring, gives you this type of layout. So on this particular node, you choose the node. You can see GPU utilization. When we start running something, you'll see this spike up, as well as other loads and memory utilization, for example, various GPU-related power metrics and such. So let's see, this is starting up. So in the meantime, let me pretend to be another user. So let me be user 3 here. So again, the box is remote, so I have to go through first the remote box, and then I can access it. So let's say the user 3 wants to run a ResNet job. So it's a very similar approach, and you can do we can start our job first. Oops. Here, all right, so here I already started the job previously. That's why you see this, but let's see if I were to do this from the beginning. All right, so here, let's start this job. Currently, again, I don't have any access to the GPUs. But if I do this, and I'm asking here 2 GPUs in this case, you'll see now that I have 2 GPUs. Otherwise, the workloads are the same. Here, I'm going to run a ResNet job. And you can see I have a TensorFlow container that I pulled down from NGC, and I can run this command to start a ResNet job. Okay, this started up. So here, while user 3 is running a ResNet job, here user 2 or user 1, let's say, is running this notebook. So I chose a Q signal. It's one of the Rapids AI one of the Rapids AI tools that we have that lets you do signal processing on GPUs. And here what we're going to do is we're going to generate a couple of signals with carriers and then just a sinusoids. And we will do various processing on it, such as calculating their frequency spectrums. So in this particular notebook, I'm gonna resample them, resample the signal, and then we'll compare the timing on the GPU versus CPU. And again, it depends what you're doing, but let's say if you are used to using signal from NumPy, and you can use Q signal to do equivalent, signal from SciPy, you can use Q signal to do equivalent work. So something like this, it might take you 4-5 seconds to run a simple resample job, whereas on a GPU, and now you can see the GPU utilization here spiked. On a GPU, it's only taking 14 milliseconds. So your speed up for this particular operation, and I profiled it, so it took a little bit more time because I did profiling to just show the speed up. So in this case, the speed up was over 300. And again, comparing here on the CPUs, that you get equivalent type of functionality and API. We're going to calculate our periodogram, which will give us the frequency spectrum. So it was a random number of carriers in this function that generated the code to begin with. And then there's again, you should refer to QSignal in this particular notebook if you're interested, but then it goes on to use PyTorch to do the detection of these signals and identifying the carriers. So here it's doing a training job. So while that is running, we can, let's look at user 3 here who's running their ResNet. And while all of that is running, you can see in here, you can see now the GPU utilization starting to spike up. So GPUs 6 and 5 are being used, and you should see additional GPUs starting to get used when the ResNet job kicks in. So another thing I like about this is, let's say I'm an admin. So let's say as an admin, I might be watching the jobs, and I could see that you have an interactive job here, and you have currently 3 jobs running. And if I want to have more details about the particular jobs, I can use this SQ, which tells me who's using how many GPUs. And so I have full control over the users as an admin. I can see them. I mean, users can also run this when they just want to see what is available and what resources are being used on the cluster. But as an admin, I can also create reservations and additional details. So, if I'm interested here, what is 28? I want to see detailed list of detailed information about the job. I can do this with this cluster API. And so this is all running in a single node, which is kind of important. And here you can see the GPU is running. Let's go back to our presentation. So this was all rootless Docker. Additionally, we have enroute PyXus. So enroute is very nice because some of the APIs that you might be running with Docker are simplified because enroute not only does it work transparently with Docker containers, so you can just use NGC containers or wherever your Docker containers are coming from, but launching them is relatively simple. So if you want to have a simple way of launching your commands, you can simplify all of these steps into a single command with something called PyXus. And PyXus adds additional options to the Slurm API, such as container image. And so let me launch one of these. Let's say test user 2. So again, I will have to log in as test user 2. So this is, let's say, my 3rd user. I mean, my 2nd user. Okay, so this user already allocated a job, and now they can just launch the job with this command. So if we just briefly look at it, you have MPI equals PMI2. What that means is you can, instead of having an explicit MPI command that you'd have to write up, this says just automatically launch MPI for me. These are the resources that you want to use. This is a container image. Container name is if you want to run this job maybe several times, it will save a session. Enroute saves this running session for you, so you can see. You don't have to reload the container each time. And then this is the ResNet, same type of job that we ran with Docker, except now we're running it with enroute. So if we launch this, it will launch the job, and you will see the GPU utilization now spike up for all of the resources that we have. So right now I have basically 3 users, right? And let's relaunch this job. 3 users, and they're all using up the jobs. And you could have much more than 3 users as well on the single job. It's just if your job cannot run, you just put it on the queue, and it will run once the resources become available. So you're not limited to just 3 users. You can have many users. In this mode, let's say if each user is only using a single GPU, it would be up to 8 users without any issues with 1 GPU per user, or however you want to distribute it. And then other jobs will also run, and they just automatically queue for you. All right. So in summary, what is DeepOps? So DeepOps aims to make managing GPU clusters flexible and scalable. And in your organization, it can range from big enterprise to small businesses, educational institutions. You can adopt and deploy DeepOps using the features that you need and are relevant to you. And my admins now have control of and management of GPUs, of scheduling policies, and resource management policies. Users can collaborate and work productively and efficiently on the shared GPUs, relying on the cluster API to handle the scheduling without stepping on each other's toes and without having to manually ping each other and bother each other about who's running what. So additionally, please refer to the blog, which has full instructions and details that we might not have covered in this presentation. We went over how to deploy DeepOps on one DGX, how to monitor GPUs run in the jobs and containers. So I hope this will help you and enable you to be more productive and have a positive experience with working on the DGX with your data science teams. Thank you very much. That's all I had for today.
Thank you, Alex. That was a great presentation. Just looking through some of the questions that were not yet answered. So here's a question for you. What is the mechanism to make the GPUs invisible in the login session?
Okay. So there's a device limit you can set up on the SSH service. Please look at the blog, and additionally in DeepOps, if you look at the detailed documentation, it talks about that. There's a whole section specifically showing you how that is done. So you can control that, because as an admin, sometimes you might want to bypass that. Let's say if you need to, update your DGX, you need to update firmware, and you just want to have access to the GPUs in your SSH session. There's a simple command to bypass that, but only someone with sudo privileges can do that.
Got it. Thank you. And another question, Alex, can you use an SBatch file rather than running a job interactively using this method?
Yes, of course. And that's really what users should probably be using, especially if they want to automate, queue up their jobs. Use SBatch. The full Slurm API is supported, so you can use any of the Slurm commands, SBatch, srun, salloc, all of those commands are supported.
All right. And then another one is, you're running DGX OS 5.0.5 on DGX1 server with B100 GPU. Does that mean that we can run the same DGX OS on older DGX systems like DGX1 or DGX2?
Yeah, so latest DGX OS, I believe it's 5, is supported in all the DGXs, all ours, from even the DGX Pascal P100s through all the latest DGX A100. yeah, the latest OS is supported that you can pull down from our enterprise support systems website. Mm.
Let me look through. Hold on. There's a question on DPops installation. I tried to install DPops per the slide given, and it keeps asking to install as a regular user. When I try that, I get permission denied. How do we install DPops? Alex, are you still there? I did see that the question was answered.
Yeah, I apologize. Okay. Yeah, I said for DPops, yeah, there could be additional steps involved. You know, you'd have to refer to the DPops documentation. Typically, as a DGX OS already installs all the required prerequisites, so you should have less problem if you're just using DGX OS. Otherwise, you might have to set up those additional prerequisites. I mean, it's relatively simple. I can try to demonstrate it here real quick, but let me kill all the jobs here because I don't want to be running jobs when I'm doing this. Yeah, you just have to, you know, let's say DPops is here. So when you set up DPops, the first thing you should do is, you know, you run scripts setup, and that will set up for you on this virtual environment with Ansible installed. And again, if you're on regular DGX OS, all the prerequisites are there. At that point, you know, if you follow that slide and you do all those configurations, you can run this playbook. You should not really be root, but you should be some user that has sudo privileges like an admin. And then the scripts will use sudo to properly run. To properly run the setup. I mean, all it is just Ansible script, and ideally it runs through the setup without issues. If there is an issue, let's say I'm running it right now, one of the services is not installed or something, it will give you that message, and then you do have to go and fix up, fix the particular issue that you might be having. Yeah. But yeah, you can ask on GitHub, you know, make a issue or file a bug there if you're having an issue or it's not clear to you how to get something working.
All right, and we have another question here. It's actually a two-part question. If Slurm gives me a third GPU from the node, then will it respond to CUDA visible devices equal 0 in the Slurm script, or do we need to use 3 or 2? And the second part to that, what if my script tries to oversubscribe using 4 GPU cards while 2 GPUs are allocated? What will happen? Will it crash or just overload?
So you are limited. Let's say I started running the script there to install. Let's see if it's. So somebody still has a job running. Yeah, I could demonstrate this. Basically, what you do is when you run, let's say you ask for several GPUs. And let's say I'll ask for 3 GPUs. At this point, you have access to 3 GPUs, and that's it. You cannot bypass this. This is all you have, and you know you might. This is how many CPUs you have. Let's say 16 CPUs that are dedicated to you. Now, when you run an application, let's say I will have some, CUDA application, you could control this further. So if I have a Docker run command here, notice I did GPUs all. But I could limit this by giving it an environment variable. You know, I could say NVIDIA visible devices equals, let's say, 0, 1. All right. Oh, sorry. So start my rootless Docker, and then I will run this guy. All right.
You have a typo in devices there. You're missing your V.
Oh, good. Thank you. So running this in real time here. NVIDIA visible devices. All right. So what this means is you have 3 GPUs, but inside this container, now you do have additional control. You will have only, you will have only those. Let me try this. You will have, this will be limited to, 601. Is this something? I don't remember the exact command. All right, so you can see here I only have, let's say, just 1. Even though on the box I reserved 3 of them. I don't remember the command, but basically there's an option to this GPUs that you specify. If it's like this, how many GPUs you might want. I don't remember the command right now. But the GPUs instead of all, you could, be specific how many GPUs you want. But you cannot, oversubscribing, it depends what you mean by that. You can run multiple processes on the same GPU. It will just overload the GPU. Sure, you can do that. But within your Slurm reservation, you cannot bypass. Your limit is 3, and then you could, use CUDA visible devices or these options to container runtimes to limit how many GPUs you're actually running an application with.
All right. I think that is all the questions that was asked or were answered. So I'd like to bring this session to a close. Thank you so much, Alex, for the great presentation and demo, and to all our panelists for supporting. So to the attendees, the recording for the session will be posted online at our customer portal. Links to the portal will be emailed to you. So join us again next month for another great session. We will send out invitations via email, or always check the DGX user forum as well, as we will post upcoming sessions there. And if you want to learn more about this, if you want a part 2 of this, this topic, please do let us know. Email dgx_info@nvidia.com, or if you have specific questions. Thanks again, and have a nice day.